Hi everyone, and welcome to another lecture video. Today we will be talking about something called a complex disk. Let's say I have a complex number z where z is equals to x plus iy. This is in general any complex number. And then I write modulus of z minus 1 is equals to 2. And as you know, how can we calculate modulus? That is, modulus of z minus 1 will be given by z minus 1 and z bar minus 1, right? Because because this 1 here is a real number. If we had a complex number over here, then we'd have to take a complex conjugate of that number as well. We will see that in another example few minutes later. So let's write it explicitly. This is x plus iy minus 1, this is x minus iy minus 1, and this is similar to x minus 1 plus iy, and this is similar to x minus 1 minus iy. Again, if this is another complex number, let's say w, this is just w bar, right? So we have x minus 1 squared plus y squared, because you know that z bar is equals to z bar z is equals to their components squared, right? That is x squared plus y squared, assuming z has this form. So let's label this equation. Let's say this is equation 1 and this is equation 2. You can see that this is actually modulus squared, right? So to take the real modulus, that is z minus 1 modulus, we have to square root it. So you have to put square roots over here, this whole thing. So now what we can write is square root over x minus 1 whole squared plus y squared is equals to 2. Now take square on both sides, that is, I square both sides like this. So this gives us x minus 1 whole square, y square is equals to 2 squared. Now this equation, let me use another color. This equation over here actually represents a circle or a disk, whatever you want to call it, because this is a standard equation for a circle with radius 2. Because we know from coordinate geometry that a circle with the radius r and center at a and b has this equation that I am writing right now. This means a circle. So let's remember that first, and with radius r. Alright, and then it has a center of a comma b. For example, if I had x plus 2 squared plus y minus 5 squared is equals to 6 squared, the center would be minus 2 comma 5 and the radius would be 6. So now let's return to our complex case. We saw that the modulus of z minus 1 is giving us this equation, that is x minus 1 whole square plus y square is equals to 2 whole square. So this actually represents this modulus of z minus 1 whole square actually represents equals to 2. This represents a circle with radius 2 and center, I should have gotten rid of these 2's, yeah, and center 1 0. because this actually gave us the equation for the circle like this, right? Let's take another example. I'll clear the canvas now. So let's say I had again a modulus z minus 2i modulus, and let's say this is equals to 1. So again I will start as before, x plus iy minus 2i modulus is equals to 1, and this time we have to take I common, and I can write it as y minus 2, right, is equals to 1. The modulus is the square root of x squared plus y minus 2 squared, which is equals to 1. So if we square it, this is just x squared plus y minus 2 whole squared, which is equals to 1 squared. Again, this is a circle with center 0, 2 and a radius of 1, and the way to see this in the complex plane is the following. First draw the x and the y's, that is the real part, and the imaginary part. So the center is at 0, that is where x equals to 0 and y equals to 2, so the center should be around here, and it has a radius 1, right? So let's say this is my 1 radius, though it doesn't look even, but and there you go, this is the circle. So this is how you can have disks in a complex plane. Thank you.